All right, so today's lesson is on limits at infinity. And limits at infinity, what we're really asking for this is the end behavior. Kind of like the very first lesson where you have to write the end behavior as a limit. We're kind of working backwards in this case. If you're asked for a limit at infinity, you're asking for where the end behavior and what the end behavior is. So if I look here for a polynomial, we know if the power term, the degree is even, either both ends go up or both ends go down. And if it's odd, one end goes up and one end goes down. So for this instance, uh, both of these go to infinity. And in this case, the right end goes to infinity and the left end goes to negative infinity. So let P be the polynomial here. So what's the limit of this? And it has to do with the power function and where that's going. So if I have a long polynomial, I just have to look at the power in the front. And wherever the power in the front is going, that will be my answer. All right, so if it's a polynomial, we're looking at the power function or the power term. The power term is the term with the biggest exponent. So here we have a polynomial. What is the power term? X to the fourth. That means both ends go up. So this says, what is the left end? If I can spell that. So negative infinity means the left end. So only looking at the power term, where's the left end going? And the answer is infinity. So understand it as end behavior. Here, infinity. You know that's the right end. So when I look at this, first of all, I identify the power term, negative x cubed. Do you know what way it goes? So negative cubed. So because the power term's negative, the right end goes down. Because it's odd, the left end goes in the other direction. Where's the right end going? And you can see the answer is negative infinity. All right, where are we looking at? The right end. What's the power term? Positive 6x squared. Where's the right end going? And the answer is infinity. Negative infinity, that's left end. What's the power term? Be careful. It's negative, so the right end goes down. Odd exponent, so the left end goes up. So where is this limit? Where is it going? Notice for all of the, positive infinity, the left end. Notice for all these ones, you could write down does not exist, and it would be accurate for each one. But I still want you to see the concept of it being infinity or negative infinity. Number 5, negative infinity. What's the power term here? There it is. The one with the biggest exponent. It's negative, so the right end goes down. Even means both ends then go down. And this is the left end. So both ends go in the same direction, but the answer is negative infinity. Here, the power term, that would be this one, negative 3x to the 7th. This is the right end. So negative means the right end is going down, so this answer is negative infinity. Turn the page. So we first looked at polynomials. When we look at reciprocal, we're still looking at power. In this case, it's power over power. So when I look at power over power, what am I looking at in terms of understanding it? So I'm not going to write this down. I'll look at number 7. Ultimately, what I'm looking at is the horizontal asymptote, or maybe the oblique and so on for us to understand it. So for this one, if I'm looking at it, I'd rather write it with one denominator in one fraction. So if I write this with one fraction, I'm going to multiply top and bottom by x to the 4th. So I have 1 subtract 7x to the 4th over x to the 4th as one fraction. Now, when I look at it, what's the power term divided by the power term? And the answer is negative 7. They just divide out. Let's look at it again. It's power divided by power. So here, the limit as x approaches negative infinity. I want to write that as one fraction. So I'm going to write it as one fraction. To do that, I'm going to multiply by x top and bottom. So that's 5 plus x, and that's over x squared. Now, when I go power over power, I want you to notice the bottom is more powerful. That means the horizontal asymptote is 0, which means the end behavior is 0, because the bottom is more powerful. Number 9. For each limit, use the property limit and so on. How do I find the end behavior of a rational? And the answer is power over power. So if I can find the limit as x approaches negative infinity of just 6x squared over 2x cubed, power over power, I'll get my answer. So when I divide this, notice the bottom is more powerful. Whenever the bottom is more powerful, the ends are going to 0 and it's over. Number 10, same idea. We have the limit as x approaches infinity. We're going to write that down. And again, power over power. In this case, it's the right end behavior. But both ends are going to, again, when the bottom is more powerful, that answer is going to be 0. Number 11. What's the limit as x approaches infinity of this? Again, it's going to be power over power. So that's 5x to the 4th over x squared. Now, when I divide this out, it's the limit as x approaches infinity of just 5x squared. They're equal to each other. And recognize that 5x squared is a polynomial that both ends, the right end and the left end, go up. So this answer is infinity. Again, the limit as x approaches infinity, power over power, we have negative x cubed and 2x squared is what I'm looking at. I'm going to simplify that. So that's negative x on top, 2 on the bottom. So I have an understanding of where this is going when I simplify it. So I simplified it. Negative x over 2 is a line. And this line has a negative slope. So if I write a line with a negative slope, where's the right end going? And the answer is, it's going to negative infinity. Number 13. The limit as x approaches infinity of this. Again, we're going power over power. Simplify it, and you get 2 over 8. Or you could get 1/4. There's your answer. Number 14. (10x cubed plus 1) and then 3 subtract 2x cubed. So we're going to write this as a limit as x approaches negative infinity, just power over power. So the power term over the power term. Know that I'm looking for the left end for this answer. I'm going to simplify this, and I'll get my answer. So the x cubes divide out, and you have negative 5. And for this, the answer is negative 5. It's just a horizontal line. So the general rules, of course, is that if the bottom is weaker, or the top is weaker, the bottom is stronger, then this answer is 0. If the top is more powerful, then it's going to go to, then the limit is either going to be positive or negative infinity. And if they're equal, then the limit's going to be the coefficient of p divided by q. But however we do it, we're going to find it by power divided by power. So if I want to find that limit, whichever direction I'm going, for a rational, we go power divided by power. We're not going to do the one on sequences. So This one on sequences, I know it breaks your heart. We're going to cross those out. Those are calculus BC goes into that. So when we get there, we get there. But right now, we're not there. So we're not going to talk about the limits of sequences right now. So those we can cross out. So the questions from 15 to 18, we're not going to handle. All right? All right, Mr. G Math, over and out. Until next time, I'm proud of you that you're doing your work.